my clock is moving. And I shut it off and you can't even tell that I'm recording it. At the end, I'll show you how to go on, or tomorrow, whatever, how to go on and retrieve this video in case you wanted to watch it or you weren't here or whatever. What happens is, a lot of times I'll pause it, which happens to me. Okay, so what I want to talk about today is your articles or your studies for statistics. They're a little bit different than your 5 W's for your English and whatnot. We ask the 5 W's, and anytime I have you do an article, I'll always have you find your 5 W's of your article. Usually it's the study, the article, and I think that's important because that kind of gives you the background information on it. The who, the what, the where, when, and why. And sometimes they're not always present. The most important one is your what. This is the guide to find first. What is being done? I'm charting the migration of turtles across the United States. So I want to look for their distance that they go every year. I want to see what their distance is. So the what is what I'm measuring. I'm measuring their distance. And the who is the turtles. The who is not who wrote my study. The who is the object of what's being done. So the what is important, and then from that we can find the who. Usually with the what, we have two different types of measurements. We have a qualitative and we have a quantitative. Of those two, which one do you think counts the numbers, like has counting in them? Quantitative. And why would you say that? Has to do with quantity. Very good. A lot of your statistics is a lot of common sense. So Courtney tells us, Courtney tells us quantity, quantitative. I'm calculator. I'm adding. I'm summing. Qualitative are things that I can't really count. The number on the back of my jersey. The number on the back of Bailey's jersey is 10. Is she the 10th one off the bench? Is she the 10th best player? Does she play 10 games? No, it's just her number. Ricky is 1. Is Ricky the best player on the team? No. Ricky? Yeah, it's just a number. There's no measurement difference between those numbers. Your zip code. Your zip code is just a number for that area that you live in. It doesn't mean because Newburgh is 12550 and New Windsor is 12553, then New Windsor has more people than Newburgh. Okay? Doesn't work that way. So quantitative is a measurement of some kind. And if it's an age, then we're in years. If you're able to measure, you usually have some kind of denomination, like height, feet, inches, centimeters, years, days, months, depending on what you're looking at. Qualitative could just be they have blue eyes, they have green eyes, they have a number on their shirt. Those are things we'll break down again. The when. We're not looking at when was this article written. We're looking at when was this study performed. When was this done? If my article came out in 2014 and I did a study for the past 5 years of my turtles migrating across the United States, when was my study done? My article came out in 2014, and I did a study for the past 5 years. So 2009 to 2014, or somewhere around there, 5 years prior to 2014. Is an easy way to say it. Just because I wrote this article in 2014, and I did a survey of 5 years before this, it might have been a little bit before that. All I have to do is say 5 years prior to 2014. Okay, it wasn't done in 2014. That's when the article came out. The when is not always as obvious. If it's not there, we say not applicable. The where is not where was this study written in, like where did I write this from my University of Pennsylvania? No, it was where was this done? across the United States. My turtles migrated across the United States. That's my where. It might have been written in the University of Pennsylvania, but the study was done across the United States. And that is not always there all the time, too. The why, sometimes we can see why, and they tell us why. Other times we have to infer this. These two, you might have to infer. Infer means you have to come up with a good reason why they must have done this. A good educated guess reason. Okay, so we can get that from the data that we collect. These are how we break down your studies, how we look at your articles. The hardest part is the what and the who. Over the years, kids somehow mix those up. Your variables. Your variables are the whats. What information are we looking for? The height of something, the weight of something, the age of something. We might also be looking for the area where they live, something qualitative about them. The color of their eyes, something qualitative. Male or female, qualitative. A lot of times they call the background work demographics. What area is this from? What male or female? What age bracket is this we're talking about? If we're looking to see what music people prefer, you want to know what age bracket you're looking at. So the younger people have a totally different sense of music than an older person does. As your parents say, please shut that off. Not anymore. Even you guys, your music is changing slightly. It's nice. Okay, so let's take a look at one of the articles I gave you, and let's see if we can break this down. Unfortunately, I don't have it on overhead, so we'll just work from here. Let's take a look at number 5. They're weighing bears, and it didn't come in that great on the weighing bears. It's what it says, though, weighing bears. Because of the difficulty of weighing a bear in the woods, researchers caught and measured 54 bears, recording their weight, their neck size, their length, and sex. They hoped to find a way to estimate weight from the other, more easily determined quantities. Okay. What's the what of this study? What's bears? Okay. Don't write this down yet, but let's talk a minute. Bears. Bears weight. What else? Sex. Neck size. Length. So we're looking at this. Good. This is the what. What are we looking for? The weight, the neck size, the length, the sex. Of what? All bears? 54 bears. These are the objects of my study. I'm looking at 54 bears. And I want to measure the what's, the variables. These are my variables. They're going to vary from bear to bear, right? And I'm going to keep track of them. Okay? I'm just counting these things. I'm keeping track of all the bears in the woods, well, that I could find 54 bears. When was this study performed? You don't know. It doesn't say. Where was this performed? It doesn't say, right? Nope, doesn't say. It says they took bears because they said because of the difficulty of weighing them in the woods, they caught several of the bears that they could, and they did take their measurements. Well, we know the bears kind of live in woods, and not in your home backyard, hopefully. You know. So yeah, it's just not specific enough. It would be nice if they stayed across the United States or in the East Coast or in the Pocono Mountains, and then we'll know exactly where. Why did they do this? Oh, good, because this tells us why. So they can estimate all the variables for the ones that they can't get a hold of. Okay, so they're approximating, they're pulling out a sample from a population of bears. Their sample is 54 bears. Well, it depends. This is their sample. Their population were all bears. We don't exactly know where this was done. If it's done across the United States, maybe 54 is not enough. If it's done from the Pocono Mountains, maybe 54 is a good amount. That's something we don't know. But we can infer that maybe they're worrying about bears becoming extinct, or bears over becoming too abundant in your area, or bears that are too large for a rural area. They have different controls they have to put on these. So maybe those are the things that they wanted to do from this study. How was this collected? Did they tell us how? Yes. They caught them in the woods, the ones they could, and they measured them. They probably tranquilized them, measured them. A lot of these studies, they put the little chips in them now, so they can track them, they can find out more information. If you watch National Geographic, the Nat Geo channels, they're like wonderful for these, like how they find all this information and do these. So when we break down a statistical article, it's a little bit different than when you look at it in the English ones, when you're looking for an English essay or an article. You're looking to see who wrote it, what was it about, where were the settings. These are a little bit different, our 5 W's. Your variables, your variables again are things that we can measure. Sometimes they're quantitative. They have measurements, feet, inches, pounds, ages, weights, neck size, inches maybe for the neck size, right? They can do inches for that. Maybe they do metrics. How about sex? Is that quantitative or qualitative? Qualitative. It's either M or F, male or female. Okay, so those are some things that we look at. And sometimes the hardest thing to find is the who. So go for the what first. What's being measured? Once you know the neck size, the sex, you say, of who? Of the 54 bears. So those are things like make it a little bit easier to find. I want you guys to take a look at number 11 and come up with your 5 W's for me. For number 11. Take a minute. All right, so we're looking at number 11. Number 11 says, fitness. Are physically fit people less likely to die of cancer? An article in the May 2002 issue of Medicine and Science in Sports and Exercise reported results of a study that followed 25,892 men aged 30 to 87 for 10 years. The most physically fit men had a 55% lower risk of death from cancer than the least fit group. What are we measuring?
The risk of death.
The risk of death. Between fitness and their health, right? Somewhere around. We have to have some kind of risk measurement to measure it. Who are we measuring this on?
25,892 men.
25,892 men. Are there more men?
Yes.
Between the ages of 30 to 87. So this is a sample from a population of all men from those ages. That's a large age group. For how many years did they do this study?
10 years
10.
prior to 2002.
10 years. Okay, so there's our when. 10 years prior to 2002. We don't know when. It could have been, 1992 to 2002. It could be 1990 to 2000, but 10 years prior to 2002. For a 10-year period. That's just, I want you to think about it for a second. Oh, sorry. I hit something. Think about this. I've got almost 26,000 men in my study, ages 30 to 87, that I followed for 10 years. Okay, and they're probably not from more than one area, because then my statistics are kind of invalid if I'm just taking one little area, unless I'm doing like that little zone. But you're going to have quite the team out there looking to test this. How do I even test a fitness level? Well, what would have been done for this? Like, if you're looking, are they physically fit? How would I test their fitness level? Yes. How they exercise. Do you notice it also says that they were 55% lower from the least fit group? Do you see that group in there? That means I probably had two groups of men, right? I want you just to think outside the box for a minute. I need to compare them. I need to give this group an exercise program. I need to know they're doing this for 10 years. For 10 years, I have to chart this and follow these people. And I make sure this group does all this exercise program for 10 years. And this group doesn't do my exercise program. And then I need to measure the risk of cancer related to their health level, their fitness level. Over 10 years, that's a lot. That's a lot to do in a study. That's what the study entails. The stuff they're just spitting back to you is the simple part of it. Okay, now that it's over, now I want to tell you that my statistics of this was that the most physically fit men had a 55% lower risk of death from cancer. Okay? We're measuring their risk of death from cancer, which is probably a very difficult thing to have to measure in the first place. But for 10 years, they charted this, and they had a group and another group. And we're going to look at that in this chapter. A control group and, a group that we don't give anything to. And we see how they fared. So this is the study that was done. Where did they do this study? Where? Where was this performed over, time? We don't know. You said NA. Oh, okay, I'm sorry. NA. We can just estimate the Y. Why did they do this? Say that again, Courtney?
To see if physically fit people were less likely to die of cancer.
Yeah, they want to see if the risk, their fitness ties in. Sorry. Fitness ties in with their risk of cancer, of death from cancer. This was the reason they did this. This is why they did this. How? We can kind of assume a little bit, because we noticed the word group in there, that they must have had at least two groups. What throws you off a little bit also is the most physically fit. Maybe they had different levels of groups. Maybe they had 3 or 4 groups. And they gave the highest level of fitness, then the next highest, then the next, and then none. And then they charted them. So they could see the most physically fit. We don't know for sure. Nobody's showing us the study. But we can infer that they had at least 2 or more groups that they measured. And we're going to find out in this chapter that we have a control group that we did give nothing to, and then the group we give the exercise to, so that we have a way to do this. We're also going to find out as we do this that when we take this sample of men, those men, even though they're in a big age group, they have to have very similar backgrounds from the population of men that we take, so that we can't be taking people that are unhealthy to begin with versus the healthiest person in the world. We have to have like similarities in your samples. So these are the things we measure. Even though you can come up with a risk, a percentage, your data that you're measuring your risk is some kind of a percentage. They probably have some kind of algorithm to calculate this risk. We don't see it because, again, we're given a little blurb